Hello, everybody. Welcome back. Today we will be talking about how to actually show two triangles are congruent using the SAS, ASA, and SSS, the postulates that we derived in the last section. So now we're going to go ahead and start writing proofs with all of this guy right here. So here's an example of a problem then. Let's say that we have the following picture on the right-hand side, which we know given is that y is the midpoint of HL, the line segment. Angle H is congruent to angle L. What I want to do is I want to prove that HW is going to be equal to FL. So anytime I do a proof, doesn't matter what type of proof it is, first thing I always like to do is mark what I have in the picture, according to what's given. Now, don't do this in the actual textbook if you can, so please, try to do this on an actual piece of paper. So here's the first part. Here's what I know. Y is the midpoint of HL. Well, if Y is the midpoint, then that tells me that these two sides right here are going to be congruent to each other. So I'm going to go ahead and mark it up like so. Next, I know that H is going to be congruent to L, so that means that this angle right here is congruent to this angle over here. Going by how we looked at the last section, that's pretty much all that's given. Then now it's just a matter of, do you see anything else that's congruent? And the answer is yes. In this case, I'm noticing that this angle right here should also be congruent to this angle right here by vertical angle. So according to my picture, now just kind of going by what we said over last time, here we have angle, consecutive side, angle. Then we have angle, consecutive side, angle. So that means the two triangles should be congruent to each other according to ASA. So now let's go ahead and set this up as a proof, so then that way we can see how this all works out. So here is going to be how it works then. First, I'm going to go ahead and look at this proof as three separate parts. I need to first show the angle are going to be congruent. Then I need to show the sides are congruent. And then I need to show that the last angle is congruent. Now, which angle is congruent first doesn't matter. You can pick whichever one you want. So in this case, let me go ahead and start with the following. The first part of the subproof, I need to show that angle H is going to be congruent to angle L. Well, that's easy enough because that's given. Now, the second part of the subproof, what I need to do is I need to show, or I need to prove that HY is going to be equal to or congruent to YL. Then the last part of the subproof is that I need to show that angle HYW is going to be congruent to angle LYF. Because as soon as I show all these three things, then what that allows me to do as like a flow chart is to say that triangle HYW is then congruent to triangle LYF by SASA, because you can kind of see it over here on the side, right? And I need to do it in this specific order of ASA because I want to show specifically ASA. If you show the side, then the angle, your reader might confuse it and think that, oh, you're going to show AA proof, which is not what we want to do. But there you go. That's the idea behind it. And once we show that the two triangles are congruent to each other, then we can say that the side HW is equal to FL because congruent parts of a congruent triangle are supposed to be congruent then. All right, so let's see how the proof actually works out in this case. So here you notice that, yes, I wrote out kind of like a skeleton or a guideline for it, and here's going to be my proof underneath. So first, we're going to go ahead and prove the first A, which is to show that H is congruent to L. Well, that's easy because that's given. Now, the second part, I need to show that HY is equal to YL. Well, that's probably where you're going to have to pull out the other given right here and work with it. Y is the midpoint of HL, so that one's given, so that's good. Next, because it's the midpoint, then we can say that HY is equal to YL by the formal definition of midpoint. Okay, so we went through that in the last chapter or last two chapters of, what's the difference between the definition of midpoint versus the midpoint theorem. One shows that the midpoint exists, whereas this definition says that the lengths are equal to each other, and that's what I want. Then the last part of the ASA proof, I need to say that the two angles right here, HYW, is congruent to LYF. So over here, Well, I know they're congruent because of the vertical angle theorem, which is something that we've used back in chapter 4. Now, if you notice, we have our ASA set up. This is kind of like writing an essay, right? You have the head, you have the first paragraph, the intro paragraph, then you have the body, and then you have the conclusion. It's exactly the same idea. So now we can say in step 5 that the two triangles are congruent to each other by ASA, like we said. And finally, since the two triangles are congruent, then we can finally say that HW is equal to FL because HW is a part of that triangle and it's the corresponding part of the other triangle. And because the two triangles are congruent that we showed in part 5, then we can say that those corresponding parts will be congruent to each other too. So the way we say it is corresponding parts of congruent triangles are congruent, which is pretty wordy. So we'll go ahead and simplify that down to CPCTC then. Okay. All right, let's look at another example of this, but using different something else besides ASA. Maybe we can do some other one like SSS or SAS. Okay, here's the next part. Next proof actually. Given that the two sides AB, the line, and PY, the line, are going to be perpendicular to each other. So you can see how down here we can kind of like see that little right angle is to indicate that they're perpendicular. I also know that AP is equal to PB. So that one is given. I want to prove that YA is congruent to YB. So let's go ahead and mark it up as to what we know and what we don't know and what we need to prove. So first we have AB is perpendicular to PY. So again, that's where we have the right angle. And then technically this is also a right angle according to maybe some of the theorems and proofs that we did, which we're going to have to use in this proof in order to show that. So that's this guy right here. So that's the first part. Next, we have AP is equal to PB. I might as well say P is the midpoint of AB then, right? So we then know that these two are going to be congruent to each other. Now, that's all the stuff that is given, and we have exhausted all the given information. We look at the two triangles and see, hey, what else are they going to have that are going to be congruent? And hopefully you guys can see it. Yeah, they share YP. So that right there is going to be congruent to itself. So according to our picture, the triangle on the left is congruent to the triangle on the right, probably by SAS then, okay? So that's how I'm going to have to show this proof. So first, again, I'm going to go ahead and write the S, the A, and then the S for my SAS proof, okay? So here, this will allow me to show that triangle APY is going to be congruent to triangle BPY. The first part, let's go ahead and get the first side, doesn't matter which one again. Let's go ahead and say that PY is equal to PY. The next one is to get angle YPA to be congruent to angle YPB. Okay, so that's going to be the next subproof. And then the last subproof is to say that AP is going to be equal to PB. If I can show all those three subproofs in my proof, then that means I have my SAS. And then I can say the two triangles are congruent. Why do I want the two triangles to be congruent? Because if you look at what I'm trying to prove right here, YA is this part right here. YB is this part right here. Having those two triangles congruent will allow me to say that those two sides are going to be congruent to each other by corresponding parts. All right, so here we go. Let's go ahead and see if we can attack this together then. First, you can see my first part is that S right here, YP is equal to YP. That's easy enough. Or actually, I wrote PY or PY up there, but it's still the same thing. So YP is congruent to YP because of the reflexive property. One thing is always equal to itself, right? So here is the first time we probably see a reflexive property being used properly. Next, I want to say that the angles are congruent, in here specifically APY and YPB. So what I'm going to do is I'm going to go ahead and take the other given, which says that AB is going to be perpendicular to PY. That's a given right there. So according to the next part right here, there are actually more than one way to show that the angles are congruent. So I'm just taking one of the few ways right here. The route that I took was I said that APY and BPY are right angles. And the reason for that is if two lines are perpendicular to each other, then they form four right angles. That is according to theorem 4.9. Now, if you want to use the definition of perpendicular, that will allow you to introduce a single right angle, but it doesn't allow you to introduce multiple right angles. And for that reason, that's why I'm actually using this. Why do I want right angles? Well, that's where the next part comes in. Here in number 4, you can see that I said APY is congruent to BPY because there is also another theorem that we learned that says any two right angles are congruent to each other. And that was theorem 4.4. A lot of the times, if I don't know the number of the theorem, which I do not, I usually just write out what it says, and I think that's actually more effective. Okay. Like I said, there's more than one way to show that two angles are congruent. If you want to go ahead and break it so that it goes from perpendicular to right angle to 90 degrees, and then afterwards you're going to show that those two are congruent because of some algebra, you could do that. But keep in mind, we did all of that in the past in like other proofs. So the question is, why reinvent the wheel? Why not use the theorems and also the postulates that we learned, so then that way we can make our proofs shorter? That's the whole point of this, right? I want to try to keep all the proofs under 10 steps, just so that way it'll be a lot easier for us. Anything we learned, we might as well use. All right, so here's the last part. AP is congruent to PB. So as of right now, we've proved this part, we proved this part, and now the last part is AP equal to PB. The answer is yes, because that was going to be given. Now, could I have slapped this up to the front for the first side and then put this one on the bottom as the last side? The answer is yes, because that's still proof SAS. Just make sure it's actually in one of those two orders then, where angle is in between. So finally, we have SAS on the side, as you can see. So triangle APY is congruent to BPY by SAS. And so now we can say that the corresponding parts, which will be the hypotenuse of those two triangles, two right triangles, are going to be congruent to each other. YA is equal to YB because of CP, CTC. All right, that should do it, hopefully. Thank you so much for watching.